Welcome to Unit 8A video for skill number 74. I can multiply, divide, and simplify rational expressions. Alright, we'll begin our notes on page 74A and we'll title it Multiplying, Dividing Rational Expressions. So a rational expression is a quotient of two polynomials, and I've given three examples here for us to take a look at. The first, we have a quadratic trinomial divided by a linear binomial. The second rational expression, what we have is a constant divided by a linear binomial, and then in the third one we have two linear binomials being divided by one another. It's possible to simplify our rational expressions, and down below I used two examples, the first two to simplify. So in the first one, in order to simplify it, what we have to do is factor out the numerator and factor the denominator, and then cancel like terms. So if we factor the numerator, we get x plus 3 times x minus 1, and in the denominator there's no need to factor it, but sometimes I include just a 1 there so that I don't forget it's there, and you'll see that in the next example, the importance. If you notice, both the numerator and the denominator have x minus 1, so we're able to cancel out those terms, and we're left with a simplified rational expression of x plus 3 over 1, or even more simply, x plus 3. Our second rational expression, we simplified by factoring the numerator, which was already factored, but we wrote 5 times 1, and you'll see why later. And then the denominator, we are able to pull a 5 out and get 5 times 2x minus 5. And now what we've noticed is the numerator and denominator both have the factor 5, so we cancel those out, and here's where that 1 shows up in the numerator, and we arrive at a final factored form of 1 divided by the quantity 2x minus 5. This works for monomials as well. When you have just a number followed by a string of variables raised to different powers, we can factor out the number. So 24 factors to 3 times 2 times 2 times 2, and 15 factors to 3 times 5. The 3's cancel, 2's and 5's don't cancel at all, and then what we have is 5x's on top and 1 on bottom, so it cancels out to x to the 4th, and then we have 2y's on top and 10 on bottom, so they cancel out to leave y to the 8th in the denominator. So when we are done simplifying a rational expression, one thing that we need to keep in mind is that there's a constraint on the domain, or there's values that we cannot plug in because we would create some sort of math conundrum. For example, we wouldn't want to plug a positive 1 into the denominator here because 1 minus 1 is 0, and we can't divide by 0. So basically, points where the denominator equals 0 are not allowed. And in the three examples that I did, the first example, x can't be 1, and the second example, x cannot be 5 halves because 2x minus 5 cannot equal 0. And then in the third example, neither x nor y can be equal to 0 because that would make the whole denominator 0. All right, on page 74b, I outline the steps for multiplying two rational expressions. And step 1 says we have to factor all the numerators and denominators completely. Step 2, we cancel out the like factors. Step 3, we multiply the numerators and the denominators. And then in final step, we identify any constraints. So let's see how this plays out in the example I've provided. Example 1. We want to multiply this rational expression by this rational expression. So in step 1, we factored the numerator and the denominator for each rational expression. So we have to do that for all numerators, all denominators. In step 2, we are canceling out like factors. And since the denominator here has an x plus 2 and the numerator here has an x plus 2, they cancel each other out. Similarly, we have an x minus 3 that cancels with an x minus 3. And after looking closer, we realize there are no more factors that can be canceled. So we move on to step 3, where we multiply our numerators. X minus 2 times x plus 1 goes in the numerator, and then x plus 2 times x plus 4 goes into the denominator. And then at this point, we are done. If we wanted to, we could write out that this is equal to x squared minus, let's see, 1x minus x minus 2 all over x squared plus 6x plus 8. Sometimes it's helpful to do that, but I refrained from it on this problem. So we move to step 4, and that's identify any constraints. And in order to do that, we do not want any zeros in the denominator. So we can't have x equal to negative 2. We can't have x equal to negative 2. We can't have x equal to negative 4. And we can't have x equal to positive 3. Okay, this process will work similarly on binomials. So what I did here was I asked us to multiply these two, not binomials, but monomials. And I factored the numerator here, 3 times 5 times x times y. And the denominator is 2 times 7 times x, y, y, y. And then I factored the numerator over here and the denominators as well. And I went through and canceled like terms. It's kind of hard to read through all this, but the 7 cancels with the 7. This 3 cancels with this 3. And the 5 cancels with the 5. We're able to take out an x. We're able to take out a y. Looks like we could cancel this x with this x. And we are all done there. So in the end, if I did everything right, we should have 7z in the numerator. And then in the denominator, we have 4x squared y to the third. And we identify any constraints finally, and that is x cannot be 0, y cannot be 0. And since we have no z's in the denominator, z can be any real number. So this was step 3, and this was step 4. Moving on to the next page. All right, in order to divide rational expressions, we just rewrite it as a multiplication of the reciprocal. So you see here in example 3, I have a division problem, and all I did was I said, leave the first term as itself, and then rather than divide, I'm going to multiply by the reciprocal. So this numerator becomes the denominator, and this denominator becomes the numerator. And now it's a multiplication problem, so I carry it out the same way I would other multiplication problems. I factor out the numerator and denominator, and then I go about canceling the like terms. So x plus 3 cancels with x plus 3. The x plus 1 here cancels with that x plus 1. X minus 3 cancels with the x minus 3. And we're left with x plus 1 over x minus 5. And finally, we identify where the constraints exist. X cannot be 3. X can't be 3, x can't be 5, x can't be negative 1, x can't be negative 3. Usually these problems will just say assume all expressions are defined, so you don't have to do this step, but it's a good habit to have. Finally, all this folds into solving a rational expression equation. So in this equation, what we have is a rational expression is set equal to 5, and all we did was we simplified the left-hand side and set it equal to 5. The x plus 1 cancels out of the top and bottom, and you get x plus 3 equals 5, which means x is equal to 2. And sometimes you'll arrive at multiple answers, but in this case we only had one, and that answer does not conflict with our constraints, so we know it's the solution. The skill test will focus on being able to do three things: being able to multiply, being able to divide, and being able to solve simple rational expressions. All right, the key concepts and ideas for Skill 74 is we should be able to identify a rational expression. So a rational expression could be a polynomial like x squared minus 6x plus 9 over another polynomial x squared minus 9. It could be also a single term polynomial like 3x squared y divided by 2x y to the fourth. And we need to be able to simplify these polynomials or these rational expressions. So in our first example, if we wanted to simplify it, we'd factor the numerator to be x minus 3 times x minus 3, and the denominator is x minus 3 times x plus 3. And these two terms cancel out, giving us x minus 3 over x plus 3 as a simplified rational expression. Simplifying the problem on the right, we get 3, we have an x on top, and then 2 with 3 y's in the denominator. We should also be able to multiply two rational expressions and then divide two rational expressions. And remember, division is simply a multiplication of the reciprocal.